Question number 16. A solid sphere of mass m and radius r is placed on a rough surface. It is subjected to different force combinations. Column 2 gives a description of frictional force acting on a sphere. Assume that a sphere does rolling motion without sliding. So if I consider entry 1 of column 1, then let friction is acting in this direction. So let the center of mass is moving in this direction and it is rotating with angular acceleration alpha about center of mass. If I write the equation of translatory and rotational motion, then the translation motion equation can be written as F plus small f is equal to mass into acceleration. And if I write the torque equation about center of mass, that F into R minus F into R is equal to moment of inertia about center of mass is 2 by 5 mr square into alpha. Alpha can be written as A by R, as the rolling is pure rolling. So on solving these two equations, we get the value of acceleration or we get the value of friction in terms of capital F. So if I solve this, it comes out to be 3F by 7 and it is positive. So the direction which we have assumed is correct. So the friction will act in rightward direction. So the correct matching will be P and the value is 3F by 7. So only P is the correct matching. In entry 2, if I draw the free body diagram, let again friction is acting in this direction. Then I have to write the equations. F is equal to mass into acceleration. Same, it is moving in this direction with acceleration A and it is rotating with angular acceleration alpha about center of mass. So this is the translational motion. So this is the translational motion equation. And if I write the torque equation, then F into R by 2 plus F into R by 2 minus F into R is equal to 2 by 5 mr square into alpha, that is A by R. So I have written this equation about center of mass. So if I solve this, the value of F comes out to be 5F by 7 and positive. So it means that the correct matching will be P as well as T. In the third entry of column 1, again that friction is acting in this direction. Then I can write F plus F is equal to mass into acceleration and F into 2R by 5 minus small f into R is equal to 2 by 5 mr square into alpha, that is A by R. So on solving these two equations, I get the value of F is equal to 0. So it means no friction force will act and the correct matching will be R. In the same way, if I solve for entry 4, then the correct matching I will get is P and S. So let's match the options. So option D is the correct answer. Let's move to question number 17. In question number 17, an ideal monatomic gas undergoes different process A to B shown in process diagram and entries in column 1. Entries in column 2 gives the value of specific capacity C and some physical characteristic of process mentioned in column 1. All the symbols have their usual meaning. So in the first entry of column 1, it is given that V is proportional to T. So for the ideal gas V is proportional to T, it means pressure is constant, and when pressure is constant, the molar heat capacity is given by Cv plus R. So that is equal to monatomic gas Cv is 3R by 2 plus R. So it comes out to be 5R by 2. And pressure at point A and B will remain same. So the correct matching will be Q only. In entry 2 of column 1, T is proportional to rho. And we know that now in the entry 3 of column 1, it is given that delta into T is constant. So if I substitute the value of delta, minus 1 by V dV by dt into T is equal to 1. So further, this can be written as V delta T plus T delta V is equal to 0, or d of T into V is equal to 0. So if derivative of something is 0, it means this is a constant. So TV is some constant, or if I replace the value of PV, then we can say that PV square is equal to constant. So again, comparing with the polytropic process, the value of X comes out to be 2. So the molar heat capacity comes out to be R by 2. Now we have to check the pressure at point A and B. So this can be further written as T into V is equal to constant. So we can see this as the temperature decrease, the volume will increase, and as the volume increase, the pressure will decrease. So the pressure at point B will be lower than the pressure at point A. So the correct matching will be R and S. In entry D of column 1, it is given that bulk modulus is minus P dP by dV. Since this angle is 45 degree and passes through the origin, so P dash is equal to P. Or I can write P is equal to minus V dP by dV. So if I write in this way, then P dV plus V dP is equal to 0, or D of P into V is equal to 0. It means the product of PV is equal to constant, or it is a isothermal process. So in case of isothermal process, the molar heat capacity is infinite. So the correct matching will be P, because the pressure at point B is more, and T. So the correct matching will be P and T. So option B is the correct answer. Let's move to question number 18.